Warm greetings, my dear students. In connection with the last class, we'll see now Fadhan's role. Okay. So far, we saw a lot of type of bondings and then dipole moment and then it's bond personalities and everything we saw. Right now, started explained you in the last class about the covalent character in ionic bonds, right? So how the ionic bonds are formed, everybody knows. And I've told you what was the first point. The smaller the size of the cation and larger the size of the anion, right? And the greater the charge on the cation, the greater the covalent character of the ionic bond. So, suppose for cations of the same size and charge, the ion with electronic configuration, if you are taking electronic configuration like n minus 1, okay, d per n, okay, n s per 0, like that, it is more polarizing than the ion with the noble gas of configuration ns to np6. So, for cations of the same size and charge, okay, so this one is more polarizing. I mean, it shows more polarity. Got it? More polarizing than the ion with the noble gas configuration. Clear, Amma? So, just keep this in your mind. Okay. Next, we are going to see about VSEPR theory. What is VSEPR theory? Valential electron pair repulsion theory. Okay. So, it determines the shapes of the molecules. Shapes of the molecules. Say, for example, covalent bonds are directional in nature, right? Okay, so and they are directed to some specified positions in space. So, covalent bonds have definite shapes. Okay, so this theory was proposed by Sidgwick and Powell and later modified by Naum and Gillespie. So, famous scientist Gillespie was. And the important postulates of this theory are the shape of the molecules depends upon the number of valence shell electron pairs. So, what it depends upon? Number of valence shell electron pairs. Okay? Electron pairs around the central atom. Okay? So, this is VSEPR. Around the central atom. Okay. So the valence shell electron pairs repel each other, right? If one atom is brought near the other atom, every atom has its own valence shell electron pairs, electrons. That is what electron pairs we are telling. Suppose if it is copper, copper has 4 electron in its outermost. It is its valence shell. And if you talk about hydrogen, hydrogen has 1 electron in its valence shell. So this electron and this electron, if you take as a pair, this is going to create a this one is going to create a pair, bond, okay, mutual sharing of pair of electron. So when I see this electron pair, if it brought close together, definitely it will repel, right? So like charges. Then in order to reduce the repulsion, the electron pairs stay at maximum distance. Okay. So the valence shell is taken as a sphere. Got it? With the electron pairs localizing on the spherical surface at maximum distance from one another. Okay. So the distance has to be maximum. Clear? A multiple bond is treated, okay, as if it is a single electron pair, and the 2 or 3 electron pairs of a multiple bond are treated as a single super pair. Clearer? So, if a molecule has resonance structure, that also we saw, this model, this VSEPR model is applicable to any such structure. Okay. Suppose if there is lone pair present, okay, lone pair of electron, it causes distortion in the expected geometry of the molecule. So the repulsion between two lone pairs of electrons is different from those between the two bond pairs. Okay, so so there are lone pairs and bond pairs. The repulsion between two lone pairs is different than between the bond pairs or between a lone pair and bond pair. So the repulsion decreases in this order. Okay, so there is a lone pair bonding. In this, repulsion is more when compared to lone pair and bond pair bonding. Okay, when compared to bond pair, okay, the repulsion is more like that. So repulsion started decreasing when bond pair to bond pair. Okay, clear? As the angle between the electron pairs increases, the repulsion also decreases. Clear? Then these are all the main points you must understand from the VSEPR theory. Then molecules containing only bond pairs of electrons. We are going to see. Okay, so first shape of the molecules. First one, molecules containing only bond pairs. Only bond pairs. Okay. Say for example, AB2 type. You are taking AB2 type where A is the central atom. Okay, this is central atom and B is the number of bond pairs. Okay. So here there are two VSEPs, right? Okay. Valence shell electron pairs are two here. Two bond pairs. In order to reduce the repulsion, these electron pairs are arranged at an angle of 180 degree. We saw as the angle between the electron pairs increases, then the repulsion also decreases, right? So we can able to extend the angle. So this is an angle, right? This is an angle between the electron pairs. Here an electron, here an electron. If this angle is, say for example, 70 degree, if you increase the angle to 180 degree, here an electron, here an electron. Get my point? Then it will be straight, right? So thus the shape of the molecule is linear, so that the repulsion is highly reduced with the bond angle of 180 degree. Okay, so this is what it is actually, the how the bond is formed, how it attains the shape. Okay, so what is the main theory, VSEPR theory? No, valence shell electron pair repulsion. So that repulsion is there so that the molecule should maintain maximum distance, and also the angle between the electron pair can also changes, or if it is increasing then the repulsion is decreasing. Okay, so always this AB2 type, it shows what? Linear symmetry, linear geometry. Okay, I can say it is linear. So many examples given in your book, you can go through. What are all the main example? BeCl2 and HgCl2, beryllium chloride, then mercury chloride, etc. Like this. Okay, then AB3 type, AB3. So this is central atom A, chlorine two bond pairs, right? Chlorine has B2, right? Like this, A, B2. Here A, B3. I can say the example of BEF3 and BCl3. So these are all the example. A, B3. Okay. So here there are how many VSEPs? Valence shell electron pairs. How much? 3. Right? This type. And in order to reduce the repulsion, these electron pairs are arranged at an angle of 120 degree. There is no other go. So these 3 bond pairs should be arranged as 120 degrees. Okay. See here it is A, B, B, B. Okay. So it attains this kind of shape. So this 120 degree attains this kind of shape. Thus the shape of the molecule is, it is known as planar triangular. Planar triangular or trigonal planar. Whatever it might be, you can write. Trigonal planar. Okay. And this bond angle you have to keep in mind. So it is bond angle 120 degree. Okay. Then AB4 type. Next. Third one is AB4 types. Okay, what is AB4 type? You know, four VSEPs are here. Okay, they are arranged at the four corners of a tetrahedron. Tetrahedron. Okay, tetrahedron. And hence the shape of the molecule is tetrahedral. Okay, how the tetrahedral can be drawn? Like this. Okay, I can draw like, okay. So next one is AB4 type. So tetrahedral. How the tetrahedral will be? So I will show you now. Okay. Like tetrahedral it is. Okay. Wow. So we have to draw four. It is four VSEPs. So like this. Okay. Hmm. Here the A will be. Okay. The bond pairs AB4. So it is tetrahedral. Okay. So, and what is its bond angle? That is very important. You have to understand the bond angle is 109 degree 28 minutes. Okay, and you can ask me like how one can able to find out the bond angle. Okay, so the bond angle is critically based on the measuring. I mean geometry only. By means of geometry, one can able to find out this angle. Okay, can you understand this? Okay. Hmm. Okay, so here AB4 type, and similarly, I will tell you about the example. I'll give you some examples like CH4, NH4 plus. Okay, that means one H plus is added. Normally it is NH3. One H plus is added here. So that's it. Okay, and ABS, you know this, right? In nitrogen has three bonds, so NH3. Okay, is it clear for you this one? Okay. Then AB5 type. AB5. Okay. So in this AB5 type, okay, 5 VSEPs to reduce the repulsion. They are arranged at the five corners. Okay, that's what. So in order to reduce its own repulsion, the molecules are arranged in such a way. Okay. So it is arranged in five corners of a trigonal bipyramid. What is it called? So AB5 type means it is definitely trigonal bipyramid. Okay. It's very interesting and you have to learn all these things. The shapes of the molecules with bond angles 120 degree and 90 degree. So the greatest example is PCl5. And I will let you know so how it will be. Okay. And this, I mean, bipyramid. I have to draw bipyramid like, okay. So this is how I should draw, and it should come like, okay, and mm, this will be, okay, here also one B was there, okay, B by pyramid, so 5, okay, B is 5 now, Cl5, and P is here the molecule A molecule is, can you able to understand this is AB5. And you know this AB6. AB6, I can say here, how many VSEPs? Six VSEPs. To reduce the repulsion, they are arranged at the six corners. Right now, how it is arranged at 5 corners. Here, 6 corners it should be arranged, and it forms an octahedron with bond angles of 90 degree. Octahedron. Okay, octahedron with bond angles of 90 degree. What is an example? Example is SF6. Okay, so sulfur is the central atom, fluorine is the bond pair atom. So it is 6. 6 is now bonded. Okay, so it can be shown like how it will be. It will be shown definitely like three-dimensional. Okay, in your book it is given very clearly. Okay, like this, and from here to here. Okay, and can you draw along with me? Then like this. Okay, then you can extend this and join this. Are you drawing with me? Okay, draw along with me. And here also one B. So every corner has B. Okay, and one more big triangle we can draw like this. Okay, like this, and like this. This also we can join. I think we hope here the A will be. Got it? Here only the A's, and remaining and all B. 1, 2, 3, 4, 5, 6. Okay, so example is S of 6. Can you able to understand? So like this, AB6 type is. So then we are going to see molecules containing both bond pairs and lone pairs. Okay, so one second. I'll show you the molecules containing bond pairs and lone pairs. Okay. You can see all shapes and structure. Okay. So mainly octahedral structure, you must understand how the molecular geometry is. Okay. So what is the type of geometry used to describe the shape of molecule and everything? So the geometry, by means of geometry only, the bond angle is calculated. I told you, no, the solid wedged line and the dotted wedged line. Okay, so these are all talking about the bonds. Okay, so and lone pair. So lone pair is described like this. Nitrogen has two lone pair. Clear? So central atom and hydrogen is now connected in between. Can you able to understand this? Okay. So what is the total number of bonds and lone pairs here? Lone electron pair is here. These are all the bonds. Okay. See, these are all the VSEPR geometries we saw already. Right? Linear, trigonal, okay, tetrahedral, everything we saw. You know how the electron is repelling. So in order to reduce the repulsion, the shape of the molecule is formed like that. Yeah. So you need to understand what it is. Electron pairs repulsion. Okay. And so this is how the repulsion takes place. Electron has to be separated in order to reduce its maximum distance. It has to move to maximum distance in order to reduce its repulsion. Okay. So that it is arranged in such a way. See how the molecule is arranged. This animation is proper. Okay, you can able to understand. See the structure and its orientation. Okay. So this is how the molecule is arranged. See, nitrogen and 3 hydrogen. This white, it shows hydrogen. Octahedral means 6. We saw now, right? One second. We saw here octahedral, right? I'll show you with this simulation actually how this is formed. Okay. One second. So we saw already the AB2 type. Okay. It is linear. This is AB2. So that means B is 2 here. B is 2 and A is 1. Central atom is 1. And B is the number of bond pairs. There are two bond pairs, right? 1 and 2. And if you add 3, then it forms, we saw, right? What is the type of AB3 molecular shape of the molecule? It is triangular or trigonal planar. We saw, right? A is here and 3 bond pairs. If you add another, if you add another one, it forms AB4 type. And what is the angle between this also, right? Show bond angles also. Right? 109 degree 28. So this is more common. Okay. 108, 109 degree, 28 minutes or 109.5 minutes, 5 degree. Okay, because 60 degree, 60 minutes carries 1 degree. 60 minutes means 1 degree. If it is 109 degree, 28 minutes, it is the half of the degree. So we can say 0.5 degree almost. Okay. So AB4 type. If you add another one, then we saw AB5 type. It is actually what type? Trigonal bipyramid. So what is the angle? 90 degree and 120 degree we saw. Right. So here it is 120 degree. Okay. So 120 degree, these three carries 120 degree and 90 degree we saw, right? These are all 90 degrees. Can you able to understand? Okay. Then AB6 type. What is the AB6 type? Okay. This one. Okay. This one is AB6 type. Okay. If you add one more, AB6, everything is 90 degree. See, all are 90 degree. It is actually octahedron. The shape of this is octahedron. Okay. Then we'll move on to molecules containing both bond pairs and lone pairs. Right now, I'll explain you that.